Alrighty, ladies and gentlemen, our next speaker in this block is Markus Holtermann. Markus is a Django core developer, has been since early 2015, with a particular focus on the migrations framework. Sucker. He developed Python and Django, he discovered Python and Django in 2010 with using on Ubuntu users.de. Markus currently lives in Berlin, Germany, and works as a back-end developer at LaterPay in Munich. Yep. Everyone, please welcome Markus to the stage.
Thanks everybody for coming and DjangoCon for having me. There's not much I want to say about me beyond what Russ introduced me. At LaterPay, we do a micropayment system for digital content. If you wanna hear more about that, talk to me. I have a lot of content in my slides and that I want to get into right now. Can I get a show of hands who has seen an email like that over the last months, years? Good. Not all of you, that's a bad thing. So essentially what this is a security announcement that the Django project released a security release of some Django version and that you probably should update. This talk is about how the Django project managed to get into a stage that we can actually send those emails and all the things that happen from, oh, we found a security issue to here's the release. First off, let's start with the security policy so we actually know what we're talking about. And pretty much at every single point in time, there are up to 4 releases of Django that are currently supported to some degree, or that receive security issues. No, not the security issues, the patches for security issues. And unsurprisingly, that's the master branch where pretty much every commit goes into anyway. The second one is the last stable release, which is 1.11 right now. Then the second last stable release, which is 1.10 right now, receives only security issues, security bug fixes. And the last LTS version that is around, which is Django 1.8. And so we have 4 versions of Django we support right now that when you probably want to be on one of those because these are the only one we provide security bug fixes for. The Django security report or and release process is a bit of a process, yeah, sure, but this is actually what the entire the purpose of this talk, telling you about this process and giving you an idea of how a security process can work. If you maintain a third-party package that's out there that people use, I highly encourage you to come up with a security process. It doesn't have to be as complex as ours, but have a security process laid out, written down, understandable for people that use your library, so that in case they find a security issue, they can report it to you or the people in charge of fixing security issues, and you have a way of informing people about these bug fixes. The preferred way for the Django project is emailing this report to the security@djangoproject.com email address. There's a team of, I don't know, 10, 15 people that monitor this email address. Pretty much all of them are volunteers, which means we can't guarantee a response within 2 hours, but we are pretty good at replying in a couple of hours. Depending on the severity of the report, you might want to check in after 2 or 3 days if we haven't replied to you at all. Once you email your report there, please do not discuss the report with anybody else, only via this email address, and don't publish it anywhere online because we need time to verify the report and eventually getting out the security release. And this is essentially where the next step of this process is, assessing the security report. Just because you think you reported a security issue doesn't necessarily mean it is a security issue. Because security is a huge topic where missing one thing can render the entire thing even invalid or valid. So when you think there's a security issue, even if you're not sure, please talk to us, please report it. We are more than happy to tell you, thank you for the report, but that's actually not an issue that is intended because of X, Y, that. Then you going and reporting this publicly, and then we're going, oh, well, shit, that's a security issue. Let's find a way to fix that as soon as possible. Given that, the security team is going to somewhat assess the security issue, the severity of all of that. In this process of assassination, we probably want to get back to you if you are not sure if what you're saying is actually what we understood. And this is also the thing that ties in with the next step, which is essentially fixing the issue. And there are two ways of fixing the issue. Either is you, with your report, potentially provide a patch to fix the issue. And this is like the best thing for us because we don't need to do the work of finding a patch for that. But it's also for you a good thing because you are becoming more than a silent contributor to Django. You will get a patch into Django. If that's something you're looking for, that's the perfect way to do that. And in the case of security issues, there's one thing about patches that is pretty much specific to security patches. Every time we provide a patch for Django, we try to keep it as backwards compatible as possible, even up to the point where we go and, well, patch is not going to get into Django unless it's going to be backwards compatible because of huge companies using us or like dozens of people and hundreds of thousands of people using Django. Screwing everybody over just for this tiny new feature is kind of a bad idea and not really what Django is about. However, if it's about security and you go and like this is one key thing that's broken, we need to fix this, and the only way to actually do this is break this one other thing, then we're much more happy to break this and have it secure than not having it secure but yeah, having this feature in there. Let's say you come up with a patch, then we're not just going to commit it and release Django. There's a whole step of validating your patch. So if you provide the patch, we are going to, the security team is going to validate your patch. It's doing a regular review on every other patch that's contributed to Django. Probably more on a security perspective involved than feature or review, like docs review or whatnot. But the point here being, there's a second set of eyes or a second group of people reviewing the patch. On the other hand, if you didn't come up with a patch but we did, we send you the patch and ask you to validate this patch, as in, does the patch we came up with actually fix the issue you reported and that you found? Or is the patch we provide just something that prevents something that mimics this issue, and we actually don't fix the underlying issue? So this confirmation step is probably the longest time in the process where emails go back and forth. Now that we have a confirmed and validated patch, we can just commit it publicly and here's a release. We could, but we don't. Because there's Django as mentioned, Django is being used by a whole bunch of organizations and distributors. Just releasing Django into the wild with a security patch is not really nice. So what we do is we have a list of pre-notification email addresses that we inform about that there's a security release upcoming, normally within the next, or in 7 days. And what we also do is we send them this patch for pretty much every supported Django version, so that when they provide Django for downstream users, so if they bundle Django in Linux repositories, for example, if they have their own Django build, they can use that patch and apply that to their Django instance, and all secure the moment they do that and deploy that. And hopefully, by the time we release Django, they have patched their systems. This list is non-public. We won't make it public. We won't tell you who is on there. There's essentially three categories of people or organizations that can be on there. The first thing being operating system vendors and distributors. Then, depending on the security issue, and essentially on a case-by-case basis, providers or distributors of other Django packages that are highly likely or are affected by the same security issue. and even also on a case-by-case basis, other entities that use Django in like huge environments, healthcare that have healthcare information behind them, lots of personal information or whatnot. What we further do is, for a couple of months, or maybe a year or two now, we announced this upcoming security release that's in a week ahead at the Django announce email address or email group or email list. And this will also give you, as a person who is who may subscribe to that or who is potentially in charge of deploying Django releases at work, the possibility to say, okay, there's a Django release coming up in 7 days at around that time with a severity of something. We probably should make sure that we have somebody around at that time who can like look at the release and see if you are affected and like potentially deploy the fix right away. And then 7 days later, there's the release. So what we do is we commit the security patch to the public repository, and essentially the moment we push those fixes, Django, the security release, the security issue has been disclosed and is public. So from that time on, there's no way back, essentially. Following that, somebody from the Django releases team is going to provide or build a Django release, submitting that, and we publish a blog post about the security issue. We will not provide an exploit, because that's kind of not the right way to do, probably, because all of a sudden everybody could just use that and hack other people's site, and that's not nice. So we published the blog post. Here's a new security issue release that fixes an issue there and there. Please update as soon as possible. And what we also do is we write to a bunch of email addresses, one of them being the Django announce email address. Here's a release. And this is essentially the email you saw in the beginning. And yeah, this is the announcement. Part of the announcement is also that we assign a so-called CVE, a common vulnerability and exposure number, to every issue we fix, which gives you the option to see if the Django release you use, so if you use a packaged Django version from Ubuntu or Debian or whatever, then the version that you use actually has fixed the issue that we disclosed. So if you use Ubuntu and don't use like a virtual environment where you pip install Django, then you want to make sure that the Django version you use has those issues fixed. And the easiest way to do that is actually checking the Ubuntu security list and seeing is this CVE fixed in the Django version I use. There's another thing about coming the way of providing a fix. And the thing here being that when you provide a fix, you did a whole bunch of work. And Django is in a lucky position of being able to pay for security bug fixes. Well, that's not quite right. It's not Django or the Django Software Foundation who is paying for that. It's depending on how we're going to pay out a bounty. It's either Facebook or Microsoft when it's happening via the HackerOne funding that we have, which means if you report a security issue that is report a security issue and potentially even fix that security issue, you have a certain credit area that we can give you as a bounty for providing us with a report. If you fix the issue yourself, then and it's being released into a Django version, then you can also go to the Google Security Patch Reward Program, and that's something that's up to you and Google. That's not something Django is involved in, and ask Google for a reward based on the severity of that fix. But the Google Reward Program also is not bound to security bug fixes. If you have this new feature that you want to introduce in Django, which increases security overall or provides a new security feature, then you can also apply at Google for getting a bounty for that new feature. And depending on like the amount of money we talk about on a security issue, it can be like $500 US or potentially even upwards. So it might be worth looking into that. Right, enough about the process. Let's talk about Django's history. And when you open the Django website, this is something you see there. Django takes security seriously and helps developers avoid many common security mistakes. And yeah, Django is reassuringly secure. Well, let's look at some numbers, right? Numbers are fun, and they lie and or may not, and statistics, you can read whatever you want in them. So I'm not a statistician. These are just the bare numbers of CVEs we have published in these years. There's nothing fancy about this statistic. You can read whatever you want from these diagrams. One thing you could think of, like Django gets more and more security issues every year. Well, true, but why? Potentially because there are just dozens of and hundreds of thousands of more people using it, and that's just the way that more people look into that and see that. Is it because Django gets more insecure, we do stupid things and open up security issues on purpose? Maybe, maybe not. No, probably not. And yeah, so there's not really these are bare numbers. There's a whole way of how you could interpret them. I'm positively surprised that the number for security reports for 2017 is still at, I think, 2. I hope it stays there, but like, who knows? So for web development, these numbers are, when we look a bit more into details of the security reports we had and classify those reports a bit in detail, then we end up with something like with this diagram. And kind of unsurprisingly, the denial of service reports we had were the most. But the interesting part is actually that the XSS reports we got are also the second most reports. So let's get into a bit of what those categories actually mean. So you have something that you can look up when you get home and look into the projects you're working on and make sure that stuff is actually not an issue in your projects. And while DOS is actually a common thing, it's not necessarily the worst thing. The worst thing in web development is not just probably, but it's definitely cross-site scripting. And when you do this in your code, then I encourage you the moment you step out of the door and go and fix this, because this is wrong. Do not do this. This is bad. Do this, where you go and parse the data, escape JSs, and then use JSON's parsing to load that. Or put it into a data attribute in HTML and use, for example, jQueries.data. That would then do the JSON parsing and magic. There's a ticket for like making something like this a bit more usable. There are Django sprints. If you want to look into that, be my guest. Happy to get involved in that as well. The other thing that is quite common are cross-site request forgery issues, or CSRF or XSRF. And when you have a link to that's a bit of a stretch here, but if you have a link, a GET request to your bank website where you have all the information that you want to transfer money from one account to another, the amount and whatnot, in the GET parameters, then you're screwed, because you can embed this link into an image tag. Well, there's probably not going to be an image loaded, but the money is still going to be transferred. So the way to protect against this is using post requests on forms and having certain tokens that can only be set in certain constraints. Then I mentioned denial of service already, and they're kind of fun, because whatever I do, I promise you, you will run into a denial of service issue yourself, and you will not even notice that until it's potentially too late. I'm not sure how many denial of service issues there were in Django, just below the half of them. We had 62 reports, security issues since 2006. I think 29 of them were DOS. The interesting one particularly interesting issue we had in Django was in Django 1.4 was with regards to the URL field. So you know the Django URL field where you can put in a domain or your entire URL. That used to have an attribute verify exists. Guess how that could go wrong? Should I go into details? The other thing is something from 2013, which wasn't just an issue in Django, but pretty much every software, like from Python, Ruby, JavaScript, Java, probably PHP as well. I have no idea, probably everything, which was called the billion laughs attack and is an attack on XML and how entity replacement in XML works. It's called 1 billion laughs. Look it up on Wikipedia. It's a genius idea of how to exploit how to do things wrong and what to think about all the things you need to think about to not screw things up and yet do that. Something that happens occasionally, it's quite a phishing attack, or easy for phishing attacks, are unvalidated redirects. So you have your login page, and you know this forgot password link there. Let's say you manage to sneak in a different domain in the email that's sent to a user than the one the user is currently on. That would mean the email the user gets has a link to a different domain for the password reset than is on your side, than the real site. Which means the password reset link points to something else, and all of a sudden the user is on a different site and potentially manages to, you have a perfect phishing attack there. And to prevent that, you need to validate whatever you have in these next parameters or wherever you redirect to be secure and to be part of your website. And this perfectly comes together with the next one, which is header poisoning. Essentially, this domain redirect or unvalidated redirect happens to be an issue of the fact that you can set a host header to something. And if it's not the intended domain but another one, then yeah, you're screwed. Who used Django 1.4? Who used Django 1.4.1? 2.3.4. You remember this issue with where all of a sudden when you started using Django 1.4 and deployed it, the entire site wasn't working anymore? So there was a thing called, or there is a thing since then called allowed hosts. That's the bug. That's essentially this is the issue that led to allowed hosts. And what I said in the beginning of let's have backwards incompatibility for security, we went with let's have allowed host as opposed to this issue. There are a couple of more. I don't have too much time left. There's something called remote code execution. There's been one report in Django which was really, really hard to trigger and not really, well, it was an issue, but it was very, very unlikely to ever be an issue. Just don't use pickle. Use something else. Authentication and authorization bypasses they happen, unfortunately. Like if you forget this login required decorator here, everybody can remove every other user, which is probably not what you want. Directory traversals used to be a thing in Django like ages ago. The last issue on that level was in 2013, so it's a couple of years ago. Essentially, what it means is you manage to access files you're not supposed to. And then, lastly, information leakage, which probably ties together with the authentication or authorization bypass, where you publish information that you didn't want to. And there's a whole different level of what you publish that you don't want. Like publishing this user exists is certainly on a different level than, and here's all the information about this user, like from password hash to email address to whatever. All these, I think about 10 categories, are summed up in the OWASP top 10, the Open Web Application Security Project. I encourage you to look that up and like browse through the reports and categories there, they give a good idea and like a good summary of what you want to look into, or what you want to watch out for when you write your whatever application. And on that note, thank you for coming. Thanks for being here. And also thanks to Florian Apollona, who helped me prepare these slides for a previous talk.